Today we're going over the Kattis problem circuit math, including whiteboarding approaches and solutions. Circuit math is an ad hoc problem that can be solved using a stack pattern. I say stack pattern since a vector STL stack can be used to solve the problem. The description is a little long, so I'll abridge it. It might be helpful if you're familiar with sequential circuits, but mastery of the topic is not necessary to solve this problem. So, given the inputs of a sequential circuit, maximum of 26, as well as the input value for each input, we are to determine the final output value of the sequential circuit. We are given the number of inputs to the circuit, a maximum of 26 inputs labeled A through Z, their values, and description of the circuit, each on their own line respectively. The first two lines are straightforward, but the last line is how we will calculate our result. Along with the characters corresponding with the input, the asterisk, plus, and minus symbols are incorporated in the third line. These correspond to the logical operators and, or, and not, where and or are two-place operators, meaning they accept two inputs to be well-formed, and the not operator is a one-place operator, meaning it accepts one input to be well-formed, usually by prefixing the character corresponding to the input. It is important to note that the third line, which we use to compute our solution, is described in postfix notation. If you're not familiar with the term, it simply means that the result of the current operation is to be evaluated from the previous or previous two input values. It should be fairly obvious why a stack is necessary to compute the result. If it is not obvious, the takeaway here is whenever you see postfix, it almost always means you use a stack to evaluate the expression. To begin, we know that we will be given the amount of inputs on the first line, so we create a variable to hold the number of inputs as well as a variable to hold the input character for the value corresponding to the letter. So I'm going to go ahead and demonstrate that right now. We also don't receive the characters corresponding to the input, but in this case, the second line provides the input values where the nth value corresponds to the nth letter of the alphabet. Once we have our input, we can create a vector that holds the current input values as well as the vector that will serve as our stack. Notice that I initialized the input values to the number of input that we received here, and they're all set to false. So the first vector is to hold our input values, and the second is to hold the current value of the evaluation as we iterate through the inputs. Now we will extract the input from the stream and assign the values based on the extracted value of the character. If you have noticed so far, the program computes the state as we receive the input. So we will continue this pattern for the loop that computes the output value of the circuit. Note that as we receive input, we will evaluate each logic gate whenever we receive the operator corresponding to the logical function. The last case is reserved to push the value of the given input onto the stack. Since there are more letters and symbols, it is easier to check for the symbol as it gets extracted from the input stream. In the case of the asterisk, we pop the two values on top and push back the result of AND onto the stack. Note that we must push back the result onto the stack for when we receive other operators from our input. If at any moment we receive more operators than we have operands, then we will get a segmentation fault. Similarly, if we receive the right amount of operators, the stack will contain exactly one value, which will be our result. The code for OR is similar to AND. As previously mentioned, not is a one-place operator, so in the case we receive a negative sign, we simply operate on the value on top. Lastly, if we're in this case of the if statement, then we must have received a letter, so we simply push the corresponding value onto the stack from a vector of values. At this point, we should be done. The loop will terminate when the input stream reaches the end of file. In other words, when we have extracted the last character. And accepted. That's it. If you notice, the solution never required iterating twice over the given input. We were able to compute the solution with extracting the input exactly once. Additionally, the final value was computed as we received our input. Anyway, I hope this video helps and have a good day.